So before we start this video, I actually wanted to talk about how I made it into the top 5 for Black Pen Red Pen's math YouTuber contest. If you want to see the other 4 YouTubers, go into the community section for Black Pen Red Pen's YouTube channel and scroll down a little and you'll see all 5 contestants, including myself. If you'd like to vote for me or for any of the other contestants in a couple of days, know that the poll will come out in a couple of days. But with that out of the way, let's get to the video. We want to solve for all the values of x and n in the equation x to the power of n equals x to the power of n plus 1 divided by n plus 1. If you know a bit of calculus, you know that this equation can come from this right here. The integral of x to the power of n for some variable x and some constant n dx is equal to x to the power of n plus 1 divided by that n plus 1. This is what we refer to as the power rule in calculus. If we want to take the integral of some x to the power of some constant, we add 1 to that constant right here and then divide by this new exponent value. But anyway, that's just a fun fact. To solve this question, we just need to do some basic algebra. First thing we can do is turn this x to the power of n plus 1 into x to the n times x to the 1. Keep in mind, we just broke this up. If there is a sum in the exponent, x to the power of some a plus b, you can break it up into x to the power of a times x to the power of b. And the reason we did this is because we now see that we can cancel x to the power of n on both the left hand and the right hand sides. This leaves us with 1 equals x divided by n plus 1. Multiplying n plus 1 on both sides gives us n plus 1 equals x. So this is the answer to this equation right here. Let's try some values. If we set n equal to 4, x would have to equal n plus 1 or 4 plus 1 or 5. Now let's plug in these values into this equation. We have 5 to the power of 4 is equal to 5 to the power of 5 divided by 5. 5 to the power of 5 divided by 5 is just equal to 5 to the power of 4, because this 5 right here is just 5 to the power of 1. And if you want to divide this, you just subtract one exponent from the other, and then you get 5 to the power of 4. And both the left hand and right hand side are equal. Let's see what happens if n equals 0. Before we say what x is, let's just plug in n equals 0 into this equation. We get x to the power of 0 equals x to the power of 1, 0 plus 1, divided by 1 again. X to the power of 0 is just 1, and that is equal to x. So that means x would have to be equal to 1 in this case, which makes sense according to our answer right here. What would happen if x is equal to 0? Again, let's just plug in x equals to 0 into our equation right here. Get 0 to the power of n equals 0 to the power of n plus 1 divided by n plus 1. 0 to the power of anything is 0, and 0 to the power of n plus 1 is also 0, so we get 0 equals 0 divided by n plus 1. So therefore, n, as long as it isn't negative 1, because then it would be 0 divided by 0, which would be a problem, which would be undefined actually, can be any value if x equals 0. Any value. If n equals negative 1, we'll have 1 divided by x, because some value to the power of negative 1 is just 1 divided by that value, equaling x to the power of negative 1 plus 1, or 1, divided by 0. This is not good. We cannot say that we cannot say that n equals negative 1, because then we get 1 divided by 0, which is undefined. Therefore, we can change our answer to be n plus 1 equaling x, but n cannot be equal to negative 1, or else this denominator will be 0, and that is a problem. We cannot have a denominator of 0. And we are done.